Let's look at writing the equation of a hyperbola in standard form. I'm given this equation here, and we first need to understand how we know that it's a hyperbola. We know that it's a hyperbola because there is an x squared and a y squared term, and they have different signs. The x squared term is positive, and the y squared term is negative. If you think about the standard form of a hyperbola equation, it is one of the variables squared, maybe shifted even, over a number, minus the other variable squared, or shifted, over a number, equals 1. Okay? So notice that x and y must be squared in a hyperbola, and in the end here, one fraction is positive, and the other fraction is negative. That corresponds to the fact that in this equation, one squared variable is positive, and the other squared variable is negative. Okay, so our goal here is to get our equation to look something like this. Now, maybe we can learn more about what our goal should be by looking at the equation we're given. For example, notice that I have an x squared term and an x term. That means I will be completing the square on the x's. If I didn't have this x term here, this negative 2x, and just had an x squared, I would not be able to complete the square, and I would just carry my x squared along for this whole ride as we're going to work in a minute. Similarly, I have a y squared and a y term, so I'll need to complete the square on the y's as well. So what that means is we will have shifted x and y's up here, not just x squared or y squared. If I did not complete the square on one of them, then over here I would have, in our goal, I would just have x squared or y squared for the one that I wouldn't complete the square. Okay? Okay, so let's get busy now. I would like to, I'm going to move all my constants to the right because I'm going to try to make that a 1 at the very end. So I might as well put my x's together on the left. And add 79 to both sides. And now what I want to do is I'm going to sort of separate my x's and my y's from each other so that I can turn those into these squared sets of parentheses up here. Okay? So the way to do that is perhaps let's think about using parentheses. So let's make x squared minus 2x. We'll sort of isolate those in their own set of parentheses. And with the y's here, I need to separate this negative 16 from the y's because whenever I do get my goal over here, I never have a number in the front of the squared part. Okay? So I need to separate this negative 16 out so that I can get my shifted y here. Notice this is just y, not like 4y or something. Okay? So I will factor my negative 16 out of the y terms, leaving me y squared plus 4y. Still equals 79. Okay, now we're going to try to turn the two things in the parentheses into perfect square trinomials so that they will factor as something squared, which is what I need over here in my goal. So complete the square. Sorry about that. On x and y. So I'm going to add something to the x's, and I'm going to add something to the y's, and then I will have to keep the equation balanced by doing the same thing to the other side. Don't worry, we'll figure out what to add in a minute. So I need to add two things to the right side, and I want to be careful here. Whenever I add this number here, I literally am adding that number, okay? So this will be the same thing on the right. Now, when I add this number, that number is actually multiplied by negative 16. So when I add the same thing to the right side, I'm going to add the blue number times that negative 16. Okay? That's the trickiest part of this. Okay, so let's figure out what we need to add now. X squared minus 2x plus 1, this will kind of be my side work here. If I were to factor that as something times itself, that would be x minus 1 times x minus 1. because that's going to give me an x squared. That's also going to give me the negative 2x. And as a result, I know that what goes here in the green spot would be negative 1 times negative 1, which is positive 1. Do the same thing on the y squared plus 4y. That would be y plus 2 times y plus 2, because that's how I would get a y squared and a 4y. And then I'm stuck with 2 times 2 is what goes here in the blue spot. Now I need to balance it by doing the same thing on the right side. So notice that the 1 here is multiplied by a hidden 1 out here. So I truly add just a 1 on the right side. But the 4 that I added here is multiplied by negative 16. So on the right side I didn't just add 4, I added 4 times negative 16 to keep both sides balanced. Okay, we're almost done. Now I'm going to factor both of those trinomials as perfect squares. So x squared minus 2x plus 1 is x minus 1 squared. Minus 16 times y plus 2 squared equals 79 plus 1 is 80. Negative 16 times 4 is negative 64. 80 minus 64 is 16. Okay? Now we need to turn this right side into the 1 that we have on this right side. So I will divide both sides by 16. And finally, when I do that, I get each of these fractions divided by 16 separately. So x minus 1 squared over 16 minus 16 y plus 2 squared over 16 equals 1. That's good. All I have left to do is to reduce this second fraction, because 16 and 16, 16 goes into 16 one time, so those each become 1s. And so my standard equation for this hyperbola is x minus 1 squared over 16 minus y plus 2 squared equals 1. And typically we like both of these to be fractions, so I will make this into a fraction by putting it over 1, and now we have the standard form of that hyperbola equation that we began with up here at the top. So this equation is the equation of a hyperbola, and it's the same as the equation that we got down here in standard form.